So dear students, in this video we are going to study a new topic, that is force between two parallel currents. Force between two parallel currents. Suppose you have a two current carrying conductor. You have a two current carrying conductor. This is conductor A, and this is a conductor B, which are d distance apart, and let IA be the current flowing in the conductor A and IB be the current flowing on the conductor B. Now from Ampere's Kittel law, the conductor B will produce some magnetic field at a distance d from the conductor B itself. That is, if I draw a Amperean loop this way, then at this distance from the wire, the value of the magnetic field produced by the conductor B will be mu 0 into the I enclosed by this Amperean loop is IB, mu 0 IB divided by 2 pi d. T is the radius of the Amperean loop. Similarly, the conductor A will also produce some magnetic field at point B, at conductor B. For example, if I make an Amperean loop this way, Amperean loop surrounding the conductor A, then at this distance, d distance, the value of the magnetic field produced by conductor A will be BA is equals to mu 0. The current enclosed by the conductor A will be IA, mu 0 IA divided by 2 pi d. Now, if you see closely, if L are the lengths of the two conductors, then this particular conductor A, which is under a magnetic field produced by conductor B, and the value of the magnetic field is this much, will experience a force. That is, current carrying conductor will experience a force in a magnetic field, and the value of the force on conductor A due to magnetic field produced by conductor B will be FAB, and it will be equals to I L cross B. Now, since the direction of the L is in this direction, and the direction of the magnetic field produced by the conductor B, the magnetic field of the direction of the magnetic field produced by the conductor B at this particular point will be, the direction of the current is in this direction, so it is outward. B, the direction of the current in B is this one, so B, so the outward. That's my four fingers. So at this point, the magnetic field are outward and this L are 90 degree with each other. So ILB sin theta, where theta will be 90 degree, and it will be just ILBB. So the value of the force will be ILBB. What is BB? BB is mu 0 IB by 2 pi d. So this is the value of the force experienced by the conductor A due to the magnetic field produced by conductor B. Similarly, now conductor B will also experience a force due to the magnetic field produced by conductor A, and it will be FBA, and it is equals to IL cross BA, which is equals to ILBA sin theta. Since at this particular point on the conductor B, the direction of the magnetic field will be downward, because the magnetic field is produced by this conductor in which the current is in this direction. That means the magnetic field is downward. So at this point the magnetic field is downward and length is directed towards this direction. So downward and this direction will make a 90 degree. That means will be IL BA. Now BA is this much. It is IL BA is mu 0 IA divided by 2 pi d. Okay, I missed something. So this is a force on conductor A due to magnetic field produced by B. So IA will be here because it is the force experienced by the conductor A. So in conductor A, IA current is flowing. So it is IA here. So IA LBB. So it is IA L mu 0 IB by 2 pi d. Similarly, this is the magnetic field on the, this is the force on the conductor B. So I am calculating the force on the conductor B due to conductor A. So it is the current on the conductor B which experiences a force due to magnetic field. So it is IB here. So IB, IB and IB. So now if you rearrange this one, FBA. If you rearrange this one, FAB will be equals to mu 0 IAIB, IAIB, L. L is the length of the conductor. L is the length of the conductor. So L divided by 2 pi d. So this is FAB. Similarly, FBA is mu 0 IAIB L divided by 2 pi d. So the magnitude of the forces are same. This particular conductor will exert some force on this one, and the same force is exerted by this conductor and this conductor. So the value of the respective forces are same. But what will be the direction of the forces? The direction of the forces are, see, since this particular conductor has a current in this direction, and I said earlier magnetic field is downward, so you can use right hand rule here. So current is in direction, magnetic current is this directed towards this direction. This finger gives me the direction of the current, and magnetic field is given by this my middle finger. So this finger in respective directions. What left? My thumb is left. So thumb will give me the direction of the force. So the force experienced by A due to magnetic field on conductor B will be outward this way. So this is the direction of FAB. Force on A due to B will be in this direction. Similarly, if you see closely, current is in this direction, the magnetic field is inward. So current is in this direction and magnetic field is inward. So current in this direction, magnetic field is inward. Okay, magnetic field is not inward here. Okay, in this case the magnetic field was outward. In this case the magnetic field was outward. This one I say it because current is in this direction for this one. So magnetic field was outward here. So magnetic field was outward. So force was in this direction. So force was in this direction. FAB. See, magnetic field is outward, current is in this direction, magnetic field is outward, so thumb is out pointed towards this direction, just opposite. So this was my FAB. Similarly for this one, magnetic field is inward, current is in this direction, so thumb is in this direction. So FBA will be in this direction. So look carefully. FAB and FB are directed against one another. One is directed towards this direction, another towards this direction. And since they have the same magnitude, that means they are equal in magnitude and opposite in direction. That means FAB will be equals to FBA. Force on A due to B is equals to force on B due to A, but the direction is opposite. That means FAB will be negative of FB. So this is the Newton's third law. In every action there is an equal and opposite reaction. Suppose if you have two currents if one has current in this direction IA, same situation, and another has current in opposite direction, IB is in opposite direction, then what might happen? So in this case, the two are attracting each other. So parallel currents are attracting each other in this case. In this case, okay, this is your homework. So if two currents are in opposite direction, then what will happen? So this is your homework. Thank you. So I might have mistaken out here. Outward. So yes, the force is in this direction. This one inward. Current is in this direction, so inward. Okay, so here they are attracting. So parallel currents attracts. So parallel currents attracts. Parallel current attracts. So these are currents are in parallel direction, same direction. So the two conductors are attracting each other. Now the two currents are in opposite direction. So what might happen here? Antiparallel currents repel each other. So you have to prove this one. This is your homework. So prove this one. Antiparallel currents repel each other in the same way that I have done. Thank you.